Thanks, everyone. It is great to be back at AWE. If you were at an Evan's keynote this morning, you got to see Specs, our brand new augmented reality glasses that build on our vision to make computing more human. We completely re-engineered our hardware stack to deliver impressive improvements to optics, weight, and core processing. Specs have a 30% larger display area, packed into a design that is 40% lighter. The optical system is 35% more transparent, ensuring natural eye contact and clear visibility. And we cut motion-to-photon latency nearly in half to an astounding 7 milliseconds, so your digital content remains seamlessly integrated with the real world. Incredible hardware is only half the story. We want to talk to you today about what's new with the software and how you can build experiences for the next generation of Specs with Lens Studio. Last year, we completely rewrote Lens Studio, our AR development platform, from the ground up to enable teams to build complex, fully fledged AR experiences. The latest Lens Studio 5.0 is a modular, lightning-fast engine with native TypeScript support for enterprise-grade coding and version control. It has Spectacles Interaction Kit for precise, hands-free tracking, built-in connected lenses for native multiplayer infrastructure, and Snap Cloud powered by Supabase, a powerful back-end as a service integrated directly into the IDE. And with Commerce Kit, select developers can accept payments for digital goods and premium features inside of lenses. Over the past year and a half, we've shipped 10 SnapOS updates with more than 40 new features and APIs. Our developer community has leveraged these features to create incredible experiences and have already published hundreds of lenses to the platform. Lenses that are delivering new AR-native gaming, learning, and utility-based experiences. Let's take the team at Ojai Studio. They've utilized our platform's advanced features like persistent anchors and spatial mapping to create a fully immersive, co-located strategy game called ASIM. This means players can experience gameplay with persistent state. Tower layouts will reload in the exact same spot where players left them. ASIM utilizes Snap Cloud, our easy-to-use, fully integrated backend for lenses to power lobbies for matchmaking, real-time spawn commands, waypoint data, tower positions, and a gear inventory with over 720 items. Snap Cloud is a perfect fit for Specs, enabling developers to create multi-level experiences, manage heavy assets, and persistent data without needing to integrate their own back-end solutions. Powerful capabilities like real-time data synchronization, edge functions, and dynamic cloud assets are all easily accessible inside of Lens Studio. Specs truly shine with shared multiplayer experiences, and we've put a lot of work into simplifying co-location and co-presence. Connected lenses allow you to seamlessly join experiences with nearby friends and family through proprietary features like Eye Connect. Simply join a shared session by looking at another person wearing Specs. For example, DB Creations built lawn games, so you can play spike ball and other outdoor games with friends, no equipment needed. We are incredibly excited about the AR developer community, and we're so proud to support your creativity and passion. Specs are a new kind of computer built for augmented reality from the ground up. They're designed for real life and built into see-through glasses. And we're improving our tools so developers can fully utilize everything Specs have to offer. For years, developers have spent serious time building core capabilities in C and C++. Spatial mapping, physics, audio, networking, navigation, sophisticated performance-critical code. And historically, if you wanted to bring any of that into a lens, you were starting from scratch. Well, not anymore. The native development kit lets you bring your existing C and C++ code directly into Lens Studio. No rewrites. No rewrites, no translation overhead. You can add native libraries to your lens and they just run. The native development kit enables low-level access to the OS, direct camera control, raw GPS and heading data, low-level networking with full cryptography support. you'll find media codecs, microphone access, all of it. NDK gives developers even more power and flexibility to build incredible performance-optimized lenses. We've been working closely with a small group of partners to put NDK through its paces. Partners with serious, decade-long investments in native code who would feel the difference immediately if it didn't work. And one of the best examples is from Mapbox. Please welcome Anu Sharma, VP of Product from Mapbox.
Thanks, Bobby. Hello, everyone. It's so great to be here. When the Specs team first approached us, they brought to us a truly interesting challenge. They wanted to build real-time AR navigation for their next-generation wearable computer, the Specs. They didn't want a flat map trapped on a screen in your hand. They wanted an ambient layer over the physical world. Imagine walking through a city, and instead of looking down at your phone, seeing live heads-up guidance that tells you exactly where to step and where to turn. That's the kind of experience that you and I could use when navigating and exploring new cities, especially when we want to do it as effortlessly as the locals. Mapbox in Specs eliminates the anxiety of missing that turn, or the awkwardness of juggling your bags while looking down at your phone and still trying to go towards your destination. In fact, it reimagines how we navigate new spaces with confidence, with awareness. Building this level of precise spatial guidance requires us to invent on many different fronts. At Mapbox, we've spent over a decade perfecting our location engine into one of the world's leading location engine and intelligence platforms for you. We process over 300 million miles of travel every day to deliver low-latency routing, precise lane-level guidance, and maps that you can style and customize for every need and use case. To support customers building applications wherever they choose, we provide SDKs for virtually every environment: iOS, Android, and embedded Linux systems. Historically, creating a new SDK for a new target environment would take weeks, if not months. We'd start with our core C++ engine, expose the APIs through a new target language, and reconfigure our CI/CD pipeline to build for that new target environment. The native development kit has completely changed this equation for us. Our team used the NDK toolchain to simply recompile the Linux SDK and run it natively on the Specs in just under 2 hours. Yeah. This is a major milestone for application and software developers like you, because now you can simply port all of your existing code and run it directly on the Specs without spending time or money. The NDK is the bridge between vast existing software ecosystems and the future of AR hardware. We at Mapbox are incredibly proud to bring our world-class location intelligence into the Specs, and we can't wait to hear what you build as all of these barriers, old and new, break down. Thank you.
Thank you, Anu. Specs NDK, native code, finally first class on a wearable. Last November, a new generation of frontier models and the agentic tools built on top of them changed how software is written. So we asked ourselves, what does a developer platform for Specs look like in this new reality? Introducing CLAD, our closed-loop agentic development framework. Here to talk to you more about CLAD is Terek Judi from the Specs product team.
Thank you so much, Bobby. Thanks, Bobby. Wow. Huge shout out to Anu and the Mapbox team. Seeing native C++ code compile straight to Specs is such a massive milestone for us. But as XR developers, we all know the hard truth. Great hardware is only as good as the software ecosystem built on top of it. Historically, content has been the single biggest bottleneck for any new computing platform, especially for AR. It takes specialized talent, new design languages, and countless hours of perfecting interactions. If every team has to start from scratch, scaling this ecosystem will take a very long time. We knew we had to drastically lower the barrier to entry. And right now, the universal answer seems to be to put some AI on it. But we didn't want to just bolt another generic AI chat window onto the side of Lens Studio and call it a day. Instead, we looked inward. We watched how our top internal teams actually build production lenses. We mapped out their exact workflows, the endless loops of prototyping, testing, optimizing, publishing, and maintaining. And we also noticed the most important part: the judgment and the craftsmanship of the people doing all this work. We then built an agentic framework of skills and agents designed to mirror and accelerate those exact loops. We call it CLAD, our closed-loop agentic development framework for specs. Now, CLAD is not a separate playground. It meets you exactly where you already work. It plugs directly into third-party coding assistants you use every day, like Anthropic's Claude Code, OpenAI's Codex, and Cursor. They all connect seamlessly through the Lens Studio MCP server. From there, agents can interact with Lens Studio, SnapCloud, the specs distribution pipelines, and specs itself for on-device live debugging tools, logs, and analytics. Connecting all the pieces of the platform with an agentic interface. It operates across 4 distinct loops. First, the design and prototyping loop. It takes your initial prompts and generates multiple UI layouts and functional prototypes, iterating in real time based on your feedback. The testing, migration, and optimization loop. One of my favorite. It instantly pushes builds straight to your specs or the simulator, catching bugs and performance bottlenecks before you even notice them. The publishing loop. It automates compliance and content moderation passes and streamlines the nuances of Lens submission, like adding metadata, privacy policies, terms of use, etc. And finally, the post-production loop. Armed with an auditable and transparent agentic identity, it runs silently in the background of your live lenses, monitoring crash reports, and automatically preparing code patches and pull requests to accelerate recovery. Now, using AI to create creative assets is cool. But today, I want to talk about how CLAD handles the mundane, frustrating, but super critical stuff. Once your code is functional, CLAD's optimization agent steps in. It inspects your project structure, analyzes your assets, gets live test logs from the device, and automatically deploys best practices to slash power, memory consumption, and reduce the thermal load. And if you've already spent the last few years building a portfolio on our legacy hardware, the migration agent automatically refactors your existing code bases, bringing them smoothly into the next generation specs platform. But we wanted to go bigger. We know that many of you have spent years making heavy investments in other 3D platforms, most notably Unity. If you're an established XR studio, rebuilding your entire application from scratch for a new platform is a big risk and a huge barrier to entry. So we built a dedicated Unity scene conversion skill in our migration loop. This pipeline reads traditional Unity projects and structures and translates visual components and scene configurations and transform hierarchies directly into native Lens Studio structures. When it hits complex C# code or foundational engine features, the migration agent acts as an intelligent translation layer. It maps those components directly into corresponding spec-specific SDK implementations, like the Spectacles Interaction Kit, UI Kit, or other native APIs. You get functional, highly optimized, native starting points on specs without weeks of manual retraining. We are incredibly excited about this, and we will be releasing the Unity Scene Conversion skill later this summer. With all this talk about autonomous agents, I want to be very clear about our philosophy. CLAD does not replace human insight. We designed these loops to accelerate iterations and automate routine workflows, not to make creative decisions for you. You are the ultimate command center. You review suggestions, steer the creative direction, and make the final call. And because agents are writing and deploying code, platform integrity cannot just be a feature. It has to be the foundation. We've built platform rails straight into our custom operating system and platform, starting with sandboxed lens execution. Every lens runs in complete isolation. If an agent writes an unstable loop, it's sandboxed. Your hardware remains perfectly stable. Data privacy by design. Trust is paramount. Specs explicitly prompts users before accessing camera and other sensitive data and signals access to bystanders through the front-facing LED. They also process as much as possible on device. Resource management. The OS enforces strict, adaptable limits on system resources so no single lens can monopolize the hardware or overheat the device. Finally, scalable content moderation. Automated scanning pipelines paired with human oversight to guarantee quality and safety before a lens even reaches an end user. Now, as AI models evolve, they excel at different tasks. To help the community navigate this, we are releasing the first version of the spatial reasoning benchmark. Available today, this benchmark systemically evaluates a model skill in core AR development areas like coordinate geometry, spatial layout, and hierarchical structures. We've run it against leading models and published the results today to help you select the right models and push the industry forward. You can start building with CLAD today. Our developer preview is live on GitHub right now. Download it, plug it into your favorite coding assistant, and start testing with the Lens Studio simulator. We are also officially opening applications for the Specs closed beta hardware program. If you have an ambitious spatial project, go to developers.specs.com and apply to visit one of our global offices to try Specs before our commercial release. We've built the tools, we've built the skills, we've built the agents, and we've built the hardware. Now it's your turn. Let's build what's next together. Thank you.